honestly, I don't know where to start. I have wanted to make this video like for a long time. I mean, not like years, but days and days, and I've prepared, and the more I read, it's so exciting. There's so much to say. Okay. Let me see. Cosmic rays. Where do they come from? They come from the cosmos. They come from the universe. They come from the sun, the solar system, our solar system, from our galaxy, from other galaxies, from the whole universe, maybe from other universes.
Our galactic home, stretching 100,000 light years from one end to the other, is a vast expanse that challenges human comprehension. As immense as our galaxy is, it's but a single speck in a universe filled with an estimated 2 trillion galaxies. Each galaxy, with its own stars, planets, and potential life, contributes to the rich story of our universe.
Sometimes they come from supernovas, which are stars that explode, and things they just like get out there, and high energy. High energy is the main thing. Okay, so we are talking about cosmic rays, and we are talking about cosmogenic dating method. Cosmogenic means formed by cosmic rays. Genic means formed by. So here we have the cosmic rays coming from the cosmos, rummet in Danish, here. And they get into our Earth's atmosphere, and they hit there the oxygen and nitrogen. Our atmosphere has 21% oxygen and 78 point something nitrogen, and the rest is all sorts of other things coming from the cosmos. So when they hit here, this is what happens. They hit one of the neutrons from the cosmic rays, hit nitrogen, and it splits into helium, 2 protons and 2 neutrons, and a separate proton, and what is left is beryllium-10. That is the primary cosmic ray up here, hits here in this case an oxygen, and it splits up, that's the spallation, splits up protons, neutrons, or neutrons, and one of these neutrons hit another oxygen, and it splits again, neutrons, protons, and that one again hit an oxygen down here. This is rock, quartz, bedrock, silicon, oxygen, dioxygen. And one of these oxygens is being hit by this neutron, and it splits up again, and what is left is beryllium-10. Maybe it looks like this. So it starts here, and it hits the first particles, and then more particles, and because they have a lot of energy, and they're all hitting here and there and everywhere, and do. Why am I talking about beryllium-10? It's because this one here is radioactive. It's radioactive, and it has a half-life of 1.4 million years. It decays. So when they use this one here in the testing, in the cosmogenic testing, as well as another one, aluminium, these help them to measure some of the things they want to know about the mountains, their age, their erosion, climate, through time, ice ages come and go. I have looked up, because we don't learn this in school. Not when I went to school. And I don't think they learn it now either. So I looked up so many things. You have no idea how much. And the more I looked up, the more I discovered, I didn't know that, and so on and so forth. And it's like, wow, so much. I said in my last video, it was used to test stone tools found in 1974, 50 years ago, in southwest Ukraine, very near the border to Hungary. They were tested many times with different methods, but no agreement could be reached. They have now been tested with the Cosmogenic method and tested to be 1.4 million years old. And so, these stone tools are now the earliest found in Europe. This method is also used in China. China used it to date the 2.1 million year old stone tools in central China in the Lüs area in Shangcheng, and were the earliest found in China. But now they are the earliest no more, because the stone tools found in Shihodu, not far from Shangcheng, have been dated also with the Cosmogenic method to be 2.43 million years old. Up in the northeast Siberia in Yakutia, it was in daring Yuri Mochanov found stone tools between 1981 and 87. They were tested to be 4.2 million years old, others 3.2 to 1.8 million years. So now these stone tools have been tested by the Cosmogenic method. An international team were up there testing the age of traces of glaciers. This team decided to test the age of those controversial stone tools. They did, and very soon their results will be published. I actually owe an apology to A.P. Derevianko, who became the director of the Institute for Archaeology and Ethnography in 1984. He took over from Klatnikov, who died in 1981. He has had a big argument with Mochanov, who found those very early stone tools in northeast Siberia. And I was really very disappointed that he would have such a big argument in, that this is no way, it can't be, and Mochanov, he said, yes, it is, and, they were kind of fighting. As the director of this Institute for the whole of Siberia, and himself a fantastic archaeologist, and I admire his work, I admire Mochanov, and I was so disappointed that he was just dismissing the whole thing. But I owe him, actually, an apology, because this technology of measuring more precisely the age of the stone tools is actually quite new. It wasn't there at all when they started the argument. It developed in the 80s, 84, Derivianco got on his post as the director. These very early stone tools in northeast Siberia were found between 84 and 87. And this method was really not known. It just started a little bit to be tried out and developed a little bit, and so of course it wasn't used. And it is only from about 1996 it started becoming a little bit more known, more used, and so on. And it is only since the last 10-15 years that it has developed even further, where they can test the stone tools, but they can also test the ground where they were found, the different layers. I am sure had they known about this method, they would have used it. Now it's being used, and very soon we can bury all the controversies and use our time for something more productive. So, my apology to Derivianco. Actually, this was my first try. There will be more, because I found so many different things which I can't put in one video. It would be hours long. But I found that, for example, the Alps are still growing up, being pressed up. And they're also eroding. And they can now find out how much of this and how much of that and so on and so forth. So it's very interesting, but very complicated. I found out also about, there's a Danish scientist, Svensmark. He has found out something about the supernovas, the cosmic rays, how they influence our climate. Now, that's exciting, because that is a whole different kettle of fish than, the CO2, etc., etc. The supernovas and the cosmic rays influence our climate. So, all that and more. I'll make more videos. I know it's not everybody's cup of tea, but I love this. So I make these videos because I think it should be known. I think that there's a lot of people like me who didn't learn this in school. And we just don't know. And we can't rely on, the usual campaigns they're running, because some of these campaigns are so political. But if you really dig and try to understand it and see what makes sense, you can learn a lot of things about what is truly happening. And so I'll make these videos because I love it. Whatever I've talked about in this video, the references are down below. Do the usual. Comment, like, comment, subscribe if you haven't done it, and bye-bye. Have a nice day.